What would happen if the moon suddenly disappeared? At first glance, it seems just a white and silent sphere in the night sky, but its presence is much more than decorative. Since time immemorial, the moon has been an accomplice to stories, legends, and discoveries. However, most of us barely suspect to what extent this natural satellite defines life on Earth and even the very fate of our planet. Why is the moon much more important than we imagine? What secrets does that surface, which seems static and dead, hide? The moon is not simply a rock orbiting around the Earth. It is a fundamental gear in the delicate cosmic clock that regulates tides, climates, and even the tilt of the Earth's axis. Without the moon, the rhythm of the oceans would lose its cadence, climate stability would be threatened, and possibly, life as we know it would be radically different. Few stop to think that the moon acts as a shield, deflecting impacts that could otherwise ravage the Earth's surface. How did it become the silent guardian of our planet? But its mysteries do not end there. Did you know that on the moon, there are mountains older than any mountain range on Earth, and that its craters tell stories of unimaginable cosmic collisions? The lunar surface, covered by dust as fine as ash but capable of challenging human technology, holds footprints that can remain intact for millions of years. What does this dust reveal to us about the past of the solar system? And why, despite seeing it every night, do we still not know all its secrets? For centuries, the moon has been inspiration, an object of study, and a challenge for science. It has guided calendars, rituals, and dreams of exploration. But what makes it so special among the hundreds of satellites that exist in the solar system? Why does its influence go far beyond what we can observe at first glance? Today, we are going to discover why the moon is much more than a satellite. It is a key piece in the great puzzle of the universe and in our own existence. What makes the moon sit right there, accompanying Earth like a silent lantern in the sky? For centuries, the origin of the moon was a mystery that fueled myths and legends, but science has ushered in a much more dramatic scenario. The most accepted theory is the giant impact hypothesis. According to this idea, about 4.5 billion years ago, an object the size of Mars, known as Theia, violently collided with the primitive Earth. The impact was so colossal that part of the material from both bodies was ejected into space, and over time, that cloud of debris coalesced to form the moon. It's as if Earth survived a cosmic accident and instead of being lost in darkness, gained an inseparable companion. Why is this theory the favorite among scientists? By analyzing the rocks brought back by the Apollo missions, experts discovered that the isotopic composition of the moon is surprisingly similar to that of Earth. If the moon had formed elsewhere in the solar system, wouldn't it be logical for it to have a distinct chemical fingerprint? This resemblance suggests that both bodies shared a common history in their origins. Furthermore, the giant impact hypothesis explains why the moon lacks a large metallic core, unlike Earth. Most of the iron remained on our planet after the collision, while the moon formed primarily from the mantle and crust. Are there other ideas about how the moon was born? Yes, but they have less support. One proposes that the moon formed at the same time as Earth, from the same cloud of dust and gas. Another suggests that the moon was an independent object captured by Earth's gravity. However, these theories fail to explain the chemical similarities or the nearly circular orbit of our satellite. It's as if they are trying to fit together pieces of a puzzle that just don't match. The origin of the moon is much more than a simple astronomical curiosity. Without that titanic collision, Earth would be a very different planet. The presence of the moon has been key to stabilizing Earth's rotational axis, and therefore, the climate that makes life possible. So, every time you look at the moon, remember that it is the result of an ancient cosmic catastrophe, a scar turned into a guardian and witness of our planet's history. What is the moon really made of? Although it may seem like a grey, dusty sphere at first glance, its composition is much more complex and fascinating. The moon is primarily made up of igneous rocks, that is, rocks that originated from the cooling of magma. The most abundant minerals on its surface are oxygen, silicon, magnesium, iron, calcium, and aluminum. But traces of elements like titanium, uranium, and thorium can also be found. Surprisingly, these materials are very similar to those found in the Earth's crust, which has been a key clue in understanding its origin. But why does the Moon lack the large amounts of water and organic matter that abound on Earth? The answer lies in its violent history and the extreme conditions of space. During its formation, the Moon was exposed to extremely high temperatures that evaporated almost all volatile compounds. That's why the lunar surface is incredibly dry and sterile, covered by a layer of fine, sharp dust called regolith. This regolith is like a mantle that envelops the Moon, formed by countless meteorite impacts over billions of years, grinding the original rocks into small particles. Are there precious metals or interesting resources on the Moon? In fact, yes. In addition to common minerals, small amounts of gold, silver, and platinum have been detected. However, what interests scientists and the space industry the most is the presence of helium-3, a rare isotope on Earth but abundant in lunar soil. This element could be the key to a future energy revolution, as it is considered a potential fuel for nuclear fusion. Although extracting it would be a huge technological challenge, the mere idea that the Moon contains such valuable energy resources makes it a strategic target. And what lies inside the Moon? Although we cannot drill into it like we do on Earth, space missions have allowed us to learn that beneath the crust lies a mantle composed of minerals like olivine and pyroxene, rich in magnesium and iron. Even deeper, there are indications of a small core, likely metallic and mostly composed of iron, with some nickel and sulfur. However, this core is much smaller, proportionally, than that of our planet. Thus, the composition of the Moon not only reveals its violent history, but also opens the door to future explorations and discoveries.
If you're enjoying this journey through the universe and want to keep exploring more cosmic mysteries, don't forget to subscribe to the channel and give the video a like. Thank you for being part of this Star Odyssey.
Have you ever wondered what lies beneath the surface of the Moon? Although from Earth we only perceive its silvery, crater-filled face, inside it hides a fascinating structure, very different from that of our planet. At first glance, one might think that the Moon is just a huge rock floating in space, but the reality is much more complex. To understand its internal structure, imagine an onion with several layers, each with its own characteristics and a crucial role in the history of the satellite. At the center of the Moon lies its core. Is it like the molten core of the Earth? Not exactly. The lunar core is small, only a few hundred kilometers in diameter, and is primarily composed of iron, with some nickel and sulfur. However, unlike the Earth's core, the Moon's is mostly solid, although some studies suggest that a thin outer layer could be partially liquid. This means that the Moon does not have an active global magnetic field like that of the Earth, making it much more vulnerable to cosmic radiation and solar wind. Surrounding the core, we find the lunar mantle. This mantle is made up of rocks rich in minerals such as olivine and pyroxene. But does the Moon's mantle have geological activity, like Earth's volcanoes and earthquakes? The answer is surprising. Although the Moon was volcanically active in the past, today its mantle is practically dormant. It only experiences small movements called moonquakes, much less powerful than Earth's earthquakes. These moonquakes are usually related to the contraction of the satellite as it cools and ages, as if the Moon is slowly shrinking. The lunar crust is the outermost layer, and the one we know best thanks to space missions. It is a rocky layer with a variable thickness that can exceed 50 kilometers in some regions. It is primarily composed of anorthosite, a rock rich in calcium and aluminum, which gives the lunar surface its characteristic light tone. Unlike Earth, the Moon's crust is filled with scars, impact craters, cracks, and vast seas of solidified basalt formed by ancient volcanic eruptions. There is no plate tectonics like on Earth, so these geographical features remain almost unchanged for millions of years. Why is it so important to know how the moon is formed from the inside? Understanding its internal structure allows us to reconstruct its history and evolution, discover why it has lost its geological activity, and better understand the formation of other rocky bodies in the solar system. Each layer of the moon is like a page from an ancient book. Together, they tell the story of one of the most influential objects in the life of our planet. Why does the moon change shape every night? This is one of humanity's oldest questions. At first glance, it seems like our satellite magically transforms, but the explanation is pure celestial geometry. The lunar phases are the result of the relative position between the Sun, the Earth, and the Moon. As the Moon orbits our planet, sunlight illuminates different portions of its surface, creating the illusion that it changes shape. Are there only two phases, the full moon and the new moon? In reality, there are 8 main phases. It all begins with the new moon, when the illuminated face is completely turned away from us, and the moon seems to disappear. Then, we see the visible crescent, a thin smile of light. This sliver grows until it reaches the first quarter, when half of the moon is illuminated. Next, the crescent continues to increase until it reaches the full moon, where the lunar disk shines fully in the sky. But the cycle doesn't end there. After the full moon, the light begins to wane. First, the waning gibbous appears. Then, the last quarter, when again only half of the moon is illuminated, but on the opposite side from the first quarter. Finally, the moon becomes thinner and thinner, passing through the waning crescent until it returns to the new moon. This complete cycle lasts about 29.5 days, known as a lunar month. It's no coincidence. Many ancient cultures base their calendars on this cycle. Have you ever wondered why we always see the same face of the moon during all its phases? It's because the moon takes exactly the same time to rotate on its axis as it does to orbit the Earth, a phenomenon called synchronous rotation. Thus, although the phases change, the face that looks at the Earth remains fixed. Interestingly, the shadows and brightness we see during the lunar phases are not caused by the Earth's shadow, but by the angle between the Sun, the Moon, and us. During the cycle of phases, the moon can appear as a thin crescent, a bright sphere, or any intermediate shape. This spectacle has fascinated humanity for millennia, inspiring calendars, festivals, and legends. The lunar phases are not just a visual phenomenon, but a direct consequence of the laws that govern the solar system. Observing them is like reading the celestial clock that marks the passage of time and the movement of the stars. What is the mystery behind lunar eclipses? This phenomenon, which has fascinated humanity since time immemorial, occurs when the Earth is positioned exactly between the Sun and the Moon. But why doesn't the Moon completely disappear during a total eclipse? The answer lies in the Earth's atmosphere. Sunlight passes through the atmosphere, scatters and tints the Moon with a reddish hue. In fact, this effect is known as the blood moon, and it is the same principle that causes the reddish sunsets on our planet. Isn't it amazing to think that during an eclipse, the moon is bathed in the colors of all the sunrises and sunsets on Earth at the same time? There are several types of lunar eclipses. The most striking is the total eclipse, when the moon is completely immersed in the darkest shadow cast by the Earth, known as the umbra. However, there are also partial eclipses, where only part of the moon enters that shadow, and penumbral eclipses, when the moon passes only through the penumbra, a region of lighter shadow, and the darkening is so subtle that it can sometimes go unnoticed. Did you know that penumbral eclipses are much more frequent than total ones, but they rarely capture our attention? Now, how often can we enjoy these celestial spectacles? Lunar eclipses only occur during the full moon phase, but not every time. This is because the moon's orbit is tilted about 5 degrees relative to the plane in which the Earth orbits the Sun. Therefore, most of the time, the Earth's shadow passes above or below the moon. Only when everything aligns perfectly does the eclipse occur. In fact, on average, there are between 2 and 4 lunar eclipses each year, although total eclipses are less common. And here's a curiosity that challenges intuition. During a lunar eclipse, the moon is visible from anywhere on Earth where it is nighttime, unlike solar eclipses, which can only be observed in very limited strips of the planet. Furthermore, lunar eclipses have historically served to confirm fundamental ideas about our world. It was during one of them that the ancient Greeks deduced that the Earth was round by observing the curved shadow cast on the lunar surface. Thus, each lunar eclipse is not only a reminder of the cosmic dance between the Earth, the Sun, and the Moon, but also a window into the history of human thought. Is it true that the Moon has a face that we never see from Earth? The answer is yes, but not because it is always dark or hidden in shadows, as is often thought. The so-called dark side of the Moon is actually a hemisphere that remains out of our sight due to a phenomenon called tidal locking. This means that the Moon takes the same amount of time to rotate on its axis as it does to orbit around the Earth, approximately 27 days and a third. Thus, it always shows us the same face, while the other remains mysterious to those observing from the Earth's surface. Why does this happen? The gravity of the Earth exerts such a strong force on the Moon that over time it slowed its rotation until it's synchronized with its orbit. It's like dancing with someone and gradually coordinating your steps to move perfectly in sync. This process took millions of years and is common in other satellite systems in the solar system. But although we call one side the dark side, in reality, the entire lunar surface receives sunlight at some point. There is no permanent dark side. What is on that far side? For centuries, humanity could only imagine it, until in 1959, the Soviet probe Luna 3 managed to photograph it for the first time. What those images revealed surprised astronomers. The hidden side is very different from the one we see from Earth. It has many more mountains, craters, and only a few seas, those large dark plains formed by ancient lava flows. In fact, 97% of the lunar seas are on the visible side, suggesting an uneven geological history that is still not fully understood. Will we ever be able to walk freely on the dark side of the Moon? Technically, we already have. In 1968, the crew of Apollo 8 was the first to see the far side with their own eyes, and since then, several missions have orbited and studied that mysterious hemisphere. Today, we know that the dark side of the Moon holds key clues about the early history of the solar system and the impacts that shaped its landscape. However, it remains a largely unexplored place, fueling the fascination and questions of those who look to the sky and wonder what secrets the hemisphere that, for billions of years, has remained out of our reach holds. What would happen if you jumped on the Moon? The answer surprises many. You could rise up to 6 times higher than on Earth. This is because lunar gravity is only 1/6 of Earth's. But why does this happen? It all relates to the mass and size of our satellite. The Moon is much smaller and less dense than Earth. Therefore, its gravitational pull is considerably weaker. If you weigh 70 kilograms here on Earth, on the Moon you would weigh just over 11. It's not magic, it's pure physics. Now, this low gravity doesn't just affect astronauts and their weight. It has profound consequences for everything that happens on the lunar surface. For example, a rock thrown into the air would take much longer to fall than on our planet. The trajectories of objects are broader, and even the dust kicked up by an astronaut's footsteps behaves very differently. It rises in elegant arcs and falls slowly, without dispersing as it would here. Can you imagine walking and seeing your own footprint drawn in the dust, remaining intact for years? Another intriguing question is, how does this reduced gravity affect human bodies? On the Moon, muscles and bones bear less load. That's why astronauts must move cautiously, as a misstep could make them jump unexpectedly or even lose their balance. Additionally, the lack of significant gravity can cause loss of muscle and bone mass if one stays there for too long. This is one of the major challenges for future long-duration missions. Would we be able to adapt to living with so little gravity? Finally, lunar gravity is key to understanding phenomena like the absence of a dense atmosphere or the retention of water on the surface. With such little gravitational force, the moon cannot trap light gases, which explains its always black sky and lack of weather. In fact, some scientists wonder if it would be possible to build tall structures or experience impossible sports on Earth thanks to this low gravity. A high jump could turn into a true flight. Lunar gravity, although small, has a huge impact on everything that happens on our fascinating satellite. Did you know that without the moon, we might have never seen the ebb and flow of the waves on the beach? The moon's influence on Earth's tides is one of nature's most fascinating phenomena. But how is it possible for such a distant object to have such power over our oceans? The answer lies in gravity. The moon's gravitational pull tugs at the oceans, creating two large bulges of water on opposite sides of the Earth, one facing the moon and the other on the opposite side. It's as if the entire planet is covered by a large blanket of water that the moon gently pulls at one end, while on the opposite side, the effect of inertia creates another bulge. And why are there two high tides and two low tides each day? This happens because the Earth rotates on its axis, while the moon remains relatively fixed in relation to us. Thus, in 24 hours, any coastal location experiences two rises and two falls in sea level. It's a constant cycle, almost like the heartbeat of a heart that sets the rhythm of marine life and many human activities. However, the moon is not the only protagonist. The sun also influences the tides, but its effect is weaker because it is much farther away. When the sun, the moon, and the Earth align, during the full moon and new moon, the tides reach their maximum strength and are called spring tides. In contrast, when they form a right angle, the tides weaken and are known as neap tides. Do tides only affect the beaches? In reality, their impact goes much further. Many marine species depend on the tides for feeding, breeding, or migrating. For example, some fish and crustaceans synchronize their life cycles with the movements of the water. Even humans have taken advantage of the tides for fishing, maritime transport, and energy production in tidal power plants. Additionally, tides help mix the waters of the oceans, distributing nutrients and regulating global temperature, which has a direct impact on climate and life on Earth. What would happen if the moon suddenly disappeared? The tides would still exist, but they would be much weaker, governed solely by the sun's attraction. This would disrupt the entire coastal ecosystem and have unpredictable consequences for marine life and for humans who depend on the oceans. So the next time you see the coming and going of the waves, remember that this everyday spectacle is the result of a precise and ancient cosmic dance between the Earth and its inseparable companion, the moon. Can the moon really influence Earth's climate? Or is it just another myth surrounding our satellite? The answer is more interesting than you might think. Although the moon does not generate storms or determine if it will rain tomorrow, it does have measurable and, in some cases, surprising effects on certain climate-related phenomena. One of the most well-known mechanisms is its influence on tides. But did you know that these variations in sea level also affect global ocean circulation? This circulation acts like a conveyor belt of heat and energy around the planet, and small alterations can impact long-term climate patterns. Is there any relationship between the moon and rainfall? Recent studies have found that during the full moon and new moon phases, the weight of the atmosphere changes slightly due to lunar gravitational attraction. This change can modify atmospheric pressure and, consequently, cloud and rain formation. Although the effect is subtle and does not cause storms on its own, some climatologists have observed a slight tendency for certain types of precipitation to coincide with specific lunar phases. It's as if the moon, from its distance, gives tiny nudges to Earth's atmosphere. Another intriguing question is whether the moon can affect winds or temperatures. The answer is that, directly, the moon does not alter daily wind or temperature, but it does contribute to the stability of Earth's rotational axis. Without the moon, the planet could wobble much more, like a top about to fall, causing extreme changes in global climate over millions of years. In fact, the stability provided by the moon is key to maintaining relatively predictable seasons and avoiding chaotic variations that would make life as we know it difficult. In summary, although the moon does not decide if you need to carry an umbrella, its presence is essential for Earth's climate balance. Through its influence on tides, atmospheric pressure, and the stability of Earth's axis, the moon acts as a kind of silent regulator. Without it, our planet would be a much more unpredictable and possibly inhospitable place. So, the next time you look up at the sky and see the moon, remember that its impact goes far beyond simple nighttime beauty. Life and climate on Earth owe it more than it seems at first glance. Did you know that the surface of the moon is marked by scars that tell the violent history of the solar system? Those holes and depressions, called craters, are nothing more than the result of billions of years of impacts from asteroids and comets. Unlike Earth, where the atmosphere and geological activity erase the traces of the past, the moon lacks protection, and its memory is practically perfect. Each crater, big or small, remains almost intact since its formation. Some of the most famous, like Tycho or Copernicus, have diameters of over 80 kilometers, and edges so defined that they seem to have been carved with precision. But why are there dark and smoother areas on the moon, known as seas, if they have never actually contained water? The name can be misleading, but these lunar seas are large plains of basalt, a volcanic rock that formed when the interior of the moon was still hot enough to cause eruptions. About 3 billion years ago, the most violent impacts fractured the lunar crust and allowed magma to burst forth and fill enormous basins. Thus, the seas were born, like the Sea of Tranquility or the Sea of Serenity, which cover almost a third of the lunar surface and give the moon that appearance of dark spots that we all recognize from Earth. Have you ever wondered why lunar craters appear so well preserved, even after millions of years? The answer lies in the lack of atmosphere and the almost complete absence of erosion. Without wind or rain, nothing erases the scars or softens the edges of the craters. Even the footprints of astronauts remain unchanged for decades. If the moon could tell its story, each crater would be a chapter of intense cosmic bombardments, and each sea a page written with cooled lava, a witness to a past much more active than it seems at first glance. Not all craters are the same. Some have central peaks formed by the rebound of the surface after the impact, while others feature ray systems that extend for hundreds of kilometers, remnants of the expelled material. The seas, on the other hand, stand out for their enormous size and shallow depth compared to the mountainous terrain that surrounds them. In fact, the lunar seas can be compared to the scars of ancient blows that, instead of sinking deeply, were filled with lava and remained as flat, dark patches. Thus, the moon is much more than just a simple satellite. It is a fossil record of the violent and creative history of our cosmic neighborhood, etched in stone and dust forever. What secrets does the lunar landscape hide beyond its well-known grey plains? Although the moon may appear to the human eye as a uniform desert, it is actually filled with mountains as imposing as those on Earth and valleys that, in some cases, surpass those of our own planet in size. Why do such surprising formations exist on a satellite with no tectonic activity like ours? The answer is written in the violent history of impacts and unique geological processes that have shaped this neighboring world. The most famous lunar mountains are often grouped into chains with evocative names, such as the Apennine Mountains, the Alps, or the Carpathians, named in honor of their terrestrial counterparts. The Apennine Mountains, for example, rise abruptly to nearly 5,000 meters in height, forming a natural wall that delineates the so-called Sea of Rains. But how did these elevations arise if the moon has no tectonic plates that move and collide with each other, as occurs on Earth? The key lies in the colossal impacts of asteroids during the infancy of the solar system. When a giant object collided with the lunar surface, the energy released was sufficient to lift gigantic rings of mountains around the impact craters. Thus were born the most impressive reliefs of the Moon, sculpted by violent collisions and extreme heat. But it's not all about heights. The lunar valleys, known as remi or linear valleys, also tell fascinating stories. Schroeter Valley, for example, is the largest canyon on the Moon, measuring over 160 kilometers in length and up to 10 kilometers wide. Its origin is just as mysterious as that of terrestrial valleys. But on the Moon, many of these grooves were not formed by rivers of water, but by incandescent lava that, flowing beneath the surface, opened cracks and channels in the crust. It's as if the Moon had, in its past, arteries of molten rock, leaving visible scars that we can still study today. Is there any mountain on the Moon that can compete with Everest? Although none reach the height of the terrestrial colossus when measured from sea level, there are peaks like Mons Huygens that rise more than 5,000 meters above the surrounding terrain. However, the absence of atmosphere and erosion means that these mountains can retain their shape for hundreds of millions of years, without wind or rain altering their profiles. If we could climb one of these peaks, we would find an unchanging view, carved by ancient impacts and preserved in the absolute silence of space. Ultimately, the mountains and valleys of the Moon remind us that, although it lacks life and the dynamic processes of Earth, its surface bears witness to a history as dramatic as that of any planet. Each ridge, each hollow, is a page from a book written by asteroid impacts and rivers of lava. Exploring these geographical features is like peering into a distant past, where time seems to have stood still and geology expresses itself in forms as simple as they are astonishing. What makes lunar dust so famous, even beyond scientists and astronauts? Lunar dust, known as regolith, covers the entire surface of the Moon like a fine grey carpet. But far from being simple dirt, it is one of the strangest and most problematic materials in the solar system. This dust formed over billions of years from the constant impact of meteorites and solar radiation. Without an atmosphere to protect it, the Moon receives direct impacts that pulverize rocks into tiny, sharp, electrically charged particles. Why are these particles so different from those we find on Earth? The answer lies in the fact that on our planet, wind and water erosion round off the grains. On the Moon, however, the regolith is as sharp as miniature blades. Did you know that this dust is one of the biggest challenges for lunar exploration? During the Apollo missions, astronauts faced unexpected problems. The dust stuck to their suits, tools, and even the interiors of the lunar modules. Why was it so rebellious? Due to the lack of moisture and electrostatic charge, the regolith clings with surprising strength and is difficult to clean. Some astronauts even compared the smell of lunar dust to that of burnt gunpowder, although, in reality, the regolith does not contain gunpowder. This aroma is due to the instant oxidation that occurs when the dust, exposed for millions of years to the vacuum, comes into contact with the oxygen in the capsules. But what makes lunar dust potentially dangerous for humans and technology? Its tiny particles can damage equipment, scratch visors, and obstruct mechanisms. Additionally, being so fine, they can reach the lungs if inhaled, posing a serious health risk during long stays. That's why future plans for lunar bases pay so much attention to regolith management. A simple walk on the surface can kick up clouds of dust that linger longer than expected due to low gravity and static electricity. Could this dust be useful for the future of humanity on the Moon? Scientists are studying how to use it as a building material, employing techniques like sintering, which involves fusing particles with heat to create bricks or roads. In this way, the very material that challenged the astronauts could become the key to building shelters and protecting against radiation. Thus, lunar dust ceases to be just an obstacle and becomes an essential part of the plans to inhabit the satellite. Is there really water on the Moon, or is it just a myth of modern science? For centuries, the idea of a barren satellite dominated our understanding. But in recent decades, science has taken an unexpected turn. How is it possible that such an apparently dry world hides one of the essential ingredients for life? The answer is surprising. The moon does have water, although you wouldn't find it in lakes or rivers like on Earth. In reality, lunar water is mainly trapped as ice within shadowed craters, mixed in the regolith and bound to minerals, forming a kind of wet dust at a microscopic level. The key to this discovery came thanks to space missions equipped with instruments capable of analyzing the light reflected off the lunar surface. But where does that water come from? There are several fascinating theories. One suggests it arrived aboard comets and asteroids that impacted the satellite billions of years ago. Another posits that solar wind, streams of charged particles emitted by the sun, could have interacted with the oxygen present in lunar rocks, forming water molecules directly there, as if the moon had a miniature chemical factory. Where is that ice hiding? The most promising place is the lunar poles, especially in craters that never receive sunlight. They are called cold traps because temperatures drop so low that any water molecule that arrives gets trapped for millions of years, as if it were in a cosmic freezer. These polar reserves, although difficult to reach, could be much more valuable than we imagine. They not only represent a crucial source for future space missions, but could also be used to produce oxygen and fuel, turning the moon into a potential gas station for deep space exploration. Now, how much water is there really? So far, studies suggest that the total amount is small compared to that of Earth, but enough to change our view of the satellite. It is estimated that in some places there could be enough ice to fill small Olympic-sized swimming pools, a modest figure in earthly terms, but revolutionary in the lunar context. The search for water on the moon is still active and is one of the greatest challenges for science and space technology. The answer to this question could determine the future of human exploration beyond our planet and make the moon the first real step towards the conquest of the solar system. What is special about observing the moon from space? It's not just a grey sphere floating in the darkness. When astronauts and space probes move away from Earth, the moon transforms before our eyes. Its appearance changes depending on the viewpoint and distance. Seen from low Earth orbit, the moon appears enormous and bright, dominating the night sky. But from greater distances, like Mars or the edge of the solar system, the moon becomes a tiny, inseparable companion of Earth, almost like a point of light traveling alongside it in the vast cosmic ocean. Did you know that from deep space, the moon and Earth can look like a kind of double planet? The distance between them is so great that, in some images taken by probes, they can be clearly distinguished as two separate spheres, dancing around each other. The Voyager 1 probe, for example, captured a historic image where Earth and the moon appear suspended in total darkness, showing how fragile and lonely our blue island is next to its satellite. From the surface of Mars, the moon and Earth look like twin stars, barely distinguishable to the naked eye. And how does the moon look from other worlds? For a hypothetical observer on the surface of Jupiter, the moon would be invisible to the naked eye due to the distance. However, from the viewpoint of a spacecraft en route to the outer planets, the moon can be used as a navigation reference, as its orbit is perfectly predictable and its brightness stands out in the sky. Additionally, the moon does not emit its own light, but its surface reflects sunlight with an intensity that makes it visible even hundreds of thousands of kilometers away, functioning as a natural beacon in the darkness of space. The moon also has a curious effect when we observe it from near-Earth space. Apollo mission astronauts described the experience of seeing the moon rise over the lunar horizon, a phenomenon known as the Earthrise. For them, the moon was a strange landscape, covered in craters and elongated shadows, while Earth appeared in the distance, colorful and vibrant, floating in the void. This perspective has changed the way we see our satellite, reminding us that the moon, although it seems always the same from Earth, is actually a dynamic and complex world, whose appearance varies radically depending on where and how we observe it in space. What motivated humanity to send machines to the moon before risking human lives? The answer is simple. The moon is an inhospitable, dangerous, and unknown place. Before even considering that a human could dream of stepping on its surface, it was essential to send robotic explorers capable of withstanding extreme conditions and transmitting vital information. Thus began a silent race, where the first probes were our eyes and ears in a world nearly 400,000 kilometers away. In 1959, the Soviet probe Luna 2 became the first human-made object to impact the lunar surface, an unprecedented achievement that opened the door to a series of increasingly complex missions. Have you ever wondered how they managed to photograph the dark side of the moon for the first time? It was thanks to the Luna 3 probe, which sent unprecedented images and revealed a lunar hemisphere completely different from the one we see from Earth. These early successes demonstrated that lunar exploration was not only possible, but necessary to better understand our satellite. As the 60s progressed, both the Soviet Union and the United States launched numerous probes. The Americans, with their Ranger program, managed to impact the moon and send thousands of photographs before self-destructing. Later, the Surveyor missions demonstrated that it was possible to land gently on the lunar regolith, analyzing soil composition and sending black and white images that amazed the world. But why was it so important to know if the surface was solid? Because there was a real fear that any spacecraft, or even an astronaut, could sink like in quicksand. The next step was even more ambitious. The Soviet vehicles, Luna 16, 17, and 18, among others, succeeded in collecting samples and sending the first rovers to the moon, like the famous Lunar 1. Can you imagine a vehicle moving on its own across the lunar surface while being controlled from Earth? The Lunar Cod, with its 8 wheels and solar panels, traveled kilometers, dodging rocks and exploring craters. Decades later, China resumed robotic exploration with its Chang'e missions, which have achieved soft landings, sample collection, and even operated rovers like Yutu-2, which investigates the moon's far side. Today, uncrewed lunar exploration remains key. Thanks to orbiters like NASA's Lunar Reconnaissance Orbiter, we have detailed maps and precise data on radiation, temperature, and lunar topography. Why do we continue to send machines instead of people? Because the moon still holds many secrets, and each robotic mission is like sending a virtual explorer capable of enduring what no human could. Thus, uncrewed lunar exploration has been, and continues to be, the perfect laboratory to pave the way for future human missions and the discovery of the deepest mysteries of our satellite. What led humanity to aim for the moon and turn the dream into reality? The Apollo program, developed by NASA in the 1960s, was much more than a technological race. It was an unprecedented feat that transformed our relationship with the cosmos. While the whole world watched, Apollo carried out a series of missions that culminated in the first manned moon landing in history. But how was such a feat achieved? And what secrets did it reveal about our natural satellite? To begin with, Apollo was not just one mission. There were several, each with a specific goal. Apollo 11, for example, was the mission that marked a turning point. On July 20th, 1969, Neil Armstrong and Buzz Aldrin set foot on the lunar surface, while Michael Collins orbited in the command module. What did they find in that unknown world? Dust as fine as talcum powder, rocks filled with history, and a landscape that seemed to be from another planet, although, in reality, it was part of ours. Each sample brought back to Earth allowed scientists to decipher fragments of the lunar past, from the origin of its craters to the mysteries of its formation. Did you know that Apollo not only aimed to walk on the moon, but also to explore it thoroughly? The astronauts set up scientific experiments such as seismographs to detect moonquakes, which are lunar earthquakes, and reflective mirrors to measure the exact distance between the Earth and the Moon. The precision of these instruments continues to amaze us today. Furthermore, it was discovered that the lunar surface is much older than previously thought, and that its rocks contain clues about the early days of the solar system. Thanks to these missions, It was confirmed, for example, that the moon is drifting away from the Earth by about 4 centimeters each year. A seemingly small curiosity, but one that has significant implications for the future. And what happened after the first moon landing? The program continued until Apollo 17, taking a total of 12 people to walk on the moon. Some astronauts even traveled several kilometers in lunar rovers, akin to joyriding in a buggy across a desert from another world. Each mission faced extreme challenges, from brutal temperatures to lunar dust, which clung to everything like glue. However, the legacy of Apollo goes beyond technology or heroism. It taught us that space is attainable and that, with ingenuity and determination, what seemed impossible can become part of human history. What if I told you that on the moon, human footprints can last for millions of years? This idea may sound like science fiction, but it is a reality that amazes scientists and curious minds alike. When the Apollo program astronauts walked on the lunar surface, every step they took left an indelible mark. Why don't those footprints disappear like they do on Earth, where wind, rain, or the simple passage of time quickly erase any trace? The key lies in the extreme conditions that prevail on the moon. Unlike our planet, the moon lacks a significant atmosphere. This means there is no wind or water to erode the soil or alter the surface. The footprints, vehicle marks, and even the remnants of scientific experiments remain exactly where they were placed. It's as if time has stopped on the lunar surface, freezing every detail in a kind of natural historical capsule. But what about exposure to the sun or meteorites? It's true that the moon is constantly bombarded by micrometeorites and experiences extreme temperature changes, from over 100 degrees Celsius during the day to less than minus 170 degrees at night. However, the erosion caused by these factors is incredibly slow. Micrometeorites can take millions of years to wear down a footprint, and solar radiation, while intense, is not enough to quickly erase the marks. In practice, the astronauts' footprints function as a time capsule, silent witnesses to human presence. And what does this tell us about our legacy beyond Earth? The footprints on the moon are tangible proof of how far humanity has come, and at the same time, a reminder of the fragility of our actions in the cosmos. On the moon, a simple step becomes permanent history, while here on Earth, time and nature take care of erasing our traces. Thus, every footprint left by the astronauts is a mark that defies time, waiting to be observed by future generations. Or perhaps by explorers from other worlds. What exactly is lunar regolith, and why does it fascinate scientists so much? Regolith is a layer of dust and rock fragments that covers the entire surface of the moon, acting like a kind of carpet that stretches from the highest peaks to the deepest craters. But, unlike the dust we find on Earth, lunar regolith is not the result of erosion by wind or water. On the moon, where there is no atmosphere or active geological processes like rain, this dust has formed over billions of years from the constant bombardment of micrometeorites and the impact of cosmic rays. Each tiny strike fractures the rocks, pulverizes them, and scatters them, creating a unique mixture that can range from particles as fine as flour to fragments the size of a walnut. What does lunar regolith feel like? The astronauts who walked on the moon compared it to dry volcanic ash, although with one key difference: the particles of regolith are incredibly sharp, almost like tiny broken crystals. This happens because, without wind or water to smooth their edges, the fragments retain their original shape, which can be a problem for spacesuits and equipment. In fact, lunar dust sticks to everything, is abrasive, and can damage filters, seals, and even electronic circuits. Did you know that lunar regolith even smells like burnt gunpowder, at least according to the astronauts' impressions? Although the moon has no scent of its own, the dust brought into the lunar modules reacted upon contact with oxygen and emitted that peculiar smell. Regolith is not just dust, it is a time capsule. In its composition, we find fragments of basalt, Minerals like pyroxenes and olivine, glasses produced by impacts, and tiny spheres called agglutinates, formed by the melting of material during meteorite collisions. Additionally, regolith contains tiny amounts of elements like helium-3, a rare isotope on Earth but relatively abundant on the lunar surface, which sparks interest for its potential use as an energy source in the future. The thickness of regolith varies. In the plains known as Maria, it can measure several meters, while in mountainous areas and craters, it can exceed 10 meters in depth. But perhaps the most intriguing aspect of lunar regolith is that it holds secrets about the history of the solar system. How does it do this? Each layer of regolith, each rock fragment or dust particle, is like a page in a book that tells the story of impacts, ancient eruptions, and the evolution of the Moon over billions of years. By studying regolith, scientists can reconstruct the frequency of meteorite bombardments, analyze the effects of solar radiation, and even search for traces of water or volatile compounds trapped in its particles. Thus, this seemingly simple grey dust becomes one of the keys to understanding not only the Moon, but also the early history of Earth and the nearby space. How much do you think the temperature on the lunar surface can vary? The answer is surprising. The Moon is one of the most extreme places in the solar system when it comes to temperature changes. While on Earth, the weather can be unpredictable, on the Moon, the difference between day and night is radical. During the lunar day, which lasts about 14 Earth days, the surface can reach temperatures exceeding 120 degrees Celsius, enough to melt lead. In contrast, as night falls, the temperature drops sharply to minus 170 degrees Celsius, colder than the coldest point in the Earth's Arctic. What causes such a brutal contrast? The key lies in the absence of a significant atmosphere. On Earth, the atmosphere acts like a blanket, retaining some heat during the night and protecting us from extremes. Without that blanket, the Moon is directly exposed to solar radiation during the day and at night radiates its heat into space with nothing to hold it back. It's like being in a desert without air, where the sun burns and the shade freezes, only multiplied by 100. These conditions pose enormous challenges for any lunar mission. Spacesuits and vehicles operating on the Moon must withstand both the scorching heat and the extreme cold. Engineers must design thermal insulation systems capable of maintaining a stable temperature inside the modules and rovers. In fact, one of the biggest challenges for future lunar bases is how to store enough energy during the long lunar night, when solar panels do not work and batteries must keep everything running for 2 weeks of darkness and freezing temperatures. Could any form of life survive such thermal swings? So far, no organism capable of withstanding these extremes has been found on the Moon. However, the study of these environments has inspired research into extremophilic life forms on Earth, which can endure similar conditions, though never as extreme. The Moon is undoubtedly a reminder of how inhospitable space can be, and the incredible engineering required to explore its secrets. Does the Moon have an atmosphere? This question has intrigued scientists for centuries. At first glance, it might seem that our satellite is surrounded by an invisible mist, but the reality is much more extreme. The Moon lacks a significant atmosphere. What exists around the Moon is an exosphere, a layer so thin and dispersed that its molecules don't even collide with each other. If we were to put all those particles in a bottle, the pressure would be almost 1,000,000 times lower than what we feel on Earth. It is literally almost a vacuum. What are the consequences of the absence of an atmosphere on the Moon? First of all, there is no air to breathe, nor protection against solar radiation or meteorite impacts. While on Earth, we live under a protective dome that filters ultraviolet rays and destroys meteoroids before they reach the ground. In the Moon, outer space is just a step away. That's why meteoroids constantly strike its surface, creating the characteristic lunar craters. Furthermore, solar and cosmic radiation arrives unimpeded, making the Moon a lethal environment for any form of life as we know it. What is that lunar exosphere made of? Its main components are helium, neon, hydrogen atoms, and traces of sodium and potassium. These particles come from the solar wind, the outgassing of the moon itself, and the impact of micrometeorites. However, there are so few that if we summed up all the mass of this atmosphere, we would barely fill a few trucks. It's as if the moon were covered by a fog so thin that it would actually be invisible, even if we were standing on its surface. And what effects does this have on daily life on the moon? Without an atmosphere, the dust kicked up by a simple step does not disperse but falls immediately to the ground. There are no colors in the lunar sky, only absolute black, even during the day. Additionally, lacking a layer to retain heat, the temperature on the surface can vary from over 100 degrees below zero at night to over 100 degrees above zero during the day. Therefore, any lunar mission must prepare for extreme thermal changes and direct exposure to space. The absence of an atmosphere also means that sounds cannot travel. On the moon, silence is absolute. Not even the faintest whisper propagates. If two people were to meet there without radios, no matter how much they shouted, they would never be able to hear each other. In summary, the lack of an atmosphere turns the moon into a hostile environment, but also into a natural laboratory to understand what Earth would be like without its invisible shield. Did you know that on the moon, light and shadow can be more extreme than in any desert on Earth? Without an atmosphere to diffuse sunlight or scatter light, the boundary between day and night on the moon is so pronounced that one boot could be under the scorching sun while the other remains in almost complete darkness. But what does this mean in practice? Sunlit surfaces can reach temperatures above 120 degrees Celsius, while shaded regions can drop below 170 degrees below zero. This radical contrast is a direct result of the lack of air, which on Earth softens the transitions between heat and cold. The moon experiences a day and night cycle that lasts approximately 29 Earth days. This means that each lunar sunrise and sunset is an extraordinarily slow event. When the sun rises over the lunar horizon, it does so gradually, casting elongated shadows that can stretch for kilometers and reveal tiny details of the surface. It's as if every little crater or stone casts its own dramatic shadow, creating landscapes that seem straight out of a science fiction movie. Why is this relevant? Because the absence of atmosphere means there is no air to scatter light. So shadows are not just dark, but absolutely black. Can you imagine walking on the lunar surface and stepping out of the sunlight? The difference would be instantaneous and brutal, like suddenly crossing the threshold of a freezer from a blazing hot surface. The Apollo astronauts experienced this firsthand. They had to be very careful with shadows, as spacesuits could dangerously overheat in the sun or cool down extremely in the shade. Moreover, visibility in the dark side becomes nearly impossible because there is no reflection to soften the darkness. Only the light from Earth, when it is full, can provide a faint glow over the lunar night landscape, barely enough to distinguish silhouettes. An intriguing question: what happens at the lunar poles, where certain craters never see sunlight? These areas of perpetual shadow are some of the coldest places in the solar system and have proven to be natural deposits of ice, protected for billions of years. The relationship between light and shadow on the moon not only creates fascinating landscapes, but also determines where water might exist, how future lunar bases are designed, and how well equipment sent by humans functions. Thus, the struggle between light and darkness on the moon is not just a visual spectacle, but a decisive factor for the future of lunar exploration. Did you know that the moon has been one of humanity's most accurate timekeepers for millennia? Long before wristwatches or digital calendars, our ancestors looked to the sky to measure the passage of time. The reason is simple. The lunar phases are as regular as the ticking of a clock, changing predictably each month. Each lunar cycle, from new moon to full moon and back, lasts about 29.5 days. This cycle, known as the synodic month, served as the basis for the earliest calendars in civilizations such as the Egyptian, Chinese, or Mesopotamian. Why the moon and not the sun? because while the sun defines the day, the moon structures the month, providing a longer and more easily observable measure in the night sky. But how exactly did the moon influence the organization of human time? The answer lies in the creation of lunar calendars, some of which are still in use today, such as the Islamic calendar and the Hebrew calendar. These systems are not based on arbitrary months, but on direct observations of the lunar phases. Each time a new moon appeared, it marked the beginning of a new month. Thus, festivities, harvests, and even daily activities were planned following the rhythm of our satellite. Even in cultures where the solar calendar predominates, the names of the months and many traditions have lunar roots. Has the moon only influenced calendars? In reality, it goes beyond that. The term month comes directly from the lunar cycle, and many languages reflect this connection. Additionally, some of the most important astronomical events, such as eclipses, have also served as time markers, allowing the ancients to predict events and establish historical chronologies. For example, several historical records have dated crucial events based on descriptions of lunar eclipses, as these are infrequent and easily identifiable events in history. However, the moon also affects time in a more literal sense. It is slowly, very slowly, slowing down the rotation of the Earth. How is this possible? Due to the gravitational interaction between the two bodies, the tides generated by the moon exert a force that reduces the Earth's spin speed. As a result, days on Earth are getting longer, albeit only a fraction of a second each century. It may seem insignificant, but over millions of years, that small change has altered the length of days and the organization of time on our planet. Thus, the moon has not only given us the month, but is also, silently, sculpting the rhythm of our day-to-day lives. Where does the belief that the moon influences people come from? Since ancient times, humanity has looked up at the night sky and seen in the moon much more than just a simple rock floating in space. In ancient Greece, for example, philosophers wondered if the silvery glow of the moon could alter the human mind. In fact, the word lunatic comes from the idea that the moon could cause madness or strange behaviors during its most intense phases. Is it just a coincidence, or is there something more behind these ancient beliefs? Many cultures have woven myths around the moon, granting it almost magical powers. In Aztec mythology, the moon was the goddess Coyolxauhqui, whose dramatic fate explained her irregular appearance and changing phases. For the Chinese, the moon is home to Chang'e, a goddess who lives eternally on its surface after drinking the elixir of immortality. Why did so many civilizations imagine the moon as a divine being or a setting for epic legends? Perhaps because, from Earth, the moon seems to change shape, disappear, and reappear, as if playing hide and seek with humanity. Is it true that the moon affects love and fertility? In India, the moon is a symbol of romance and fertility, and its cycle of approximately 29 days has been linked for centuries to female menstrual cycles. In other cultures, it was believed that planting seeds under the light of the full moon would ensure abundant harvests, while performing rituals during an eclipse could attract good luck, or conversely, unleash chaos. Does the moon really have that power, or has it simply become a mirror of human desires and fears? But not all stories are about gods and magic. In medieval Europe, the moon was feared by peasants, who believed that under its glow, creatures like werewolves or witches could appear. Perhaps the moon, by illuminating the darkness, brought life to the shadows and mysteries of the night. What does this tell us about our relationship with the satellite? Perhaps that the moon has been, and continues to be, a blank canvas where humanity projects its dreams, fears, and the need to find meaning in the sky. Despite scientific advances, the moon continues to feed the collective imagination, reminding us that, although we understand it better, it will never cease to inspire legends. What is it about the moon that has fascinated artists and writers for millennia? From the earliest prehistoric engravings to contemporary poetry, the moon has been an unyielding muse. Why does this cold, distant satellite manage to evoke so many emotions? The answer may lie in its silent yet constant presence in our nights, shaping not only the tides but also the human imagination. For many ancient peoples, the moon was a goddess, a symbol of mystery, femininity, and eternal cycles. In literature, its silvery light has served as a backdrop for promises, awakenings, and transformations, as seen in tales of werewolves or love stories under the full moon. Did you know that the first literary mention of the moon dates back over 4,000 years? In Sumerian poems? Since then, its image has traveled through mythologies, epics, and novels. Shakespeare used it as a witness to impossible loves and magical nights in A Midsummer Night's Dream. Later, romantic poets like Gustavo Adolfo Bécquer and Federico Garcia Lorca gave the moon a voice of its own, turning it into a symbol of melancholy, desire, or fate. Even in science fiction, the moon has been a protagonist. Jules Verne imagined a journey to it when it was still impossible to think of rockets and astronauts. Isaac Asimov incorporated it into his stories about space colonization, and popular culture transformed it into a stage for adventures and mysteries. But the moon has not only inspired words, it has also been a muse for painting, music, and film. Why have so many artists tried to capture its essence? Perhaps because its light changes the landscape, tinting the world with unreal, almost magical tones. In painting, the moon appears in works by Vincent van Gogh, such as Starry Night, and in the romantic landscapes of Caspar David Friedrich. In music, Claude Debussy composed Clair de Lune, a piece that translates the serenity and mystery of the satellite into notes. Cinema, from the shorts of Georges Méliès to contemporary science fiction films, has made the moon a setting for dreams, terrors, and human desires. Is there any other celestial presence that has marked human culture as much? The moon is a mirror and refuge, a symbol of duality. Light and shadow, closeness and distance, constancy and change. Its influence on art and literature is as persistent as its phases in the sky. Each generation finds in it a reason to create, reinvent, and dream. Thus, the moon remains not only as an astronomical object, but as one of the great engines of human creativity, reminding us that, although science may unveil its secrets, there will always be space for poetry and imagination. Can the full moon really influence our behavior? This question has fascinated humanity for centuries. Since ancient times, some claim that during full moon nights, people act strangely. More insomnia, more births, more crimes, and even more madness. In fact, the word lunatic comes from the belief that the moon could affect the human mind. But is there any scientific basis behind all these stories? Looking at modern scientific studies, the answer is much less mysterious than it seems. Numerous experiments have tried to find a direct relationship between the full moon and changes in human behavior, such as increased violence, frequency of births, or the occurrence of sleep disorders. However, most results do not show a statistically significant connection. For example, analyses of police and hospital records from different countries have concluded that full moon nights do not bring more crimes or emergencies than any other lunar phase. Moreover, some scientists suggest that the belief in the power of the full moon is a clear example of confirmation bias. We remember unusual events when they coincide with the full moon and forget those that occur on other nights. Now, is there any biological explanation that justifies even a small effect of the moon on our behavior? It is true that the moon influences tides and, therefore, some biological cycles of marine animals. However, in the case of humans, whose daily lives are much more guided by artificial light and clocks, the direct impact of moonlight is minimal. Still, there are studies exploring whether the increased brightness during the full moon could affect sleep, as in the absence of curtains or blinds, the room may be brighter. But even here, the results are contradictory, and in general the differences are so small that they go unnoticed by most people. So why does the full moon remain so present in myths and legends about madness, passion, or nocturnal mysteries? The answer may lie in our need to seek patterns and explanations for the unexpected. The full moon is easy to identify and memorable, a large bright sphere dominating the sky. If something unusual happens on such a night, we tend to associate it with that visible phenomenon, even if it is just a coincidence. Thus, the full moon becomes the protagonist of stories, songs, and superstitions, much more powerful in culture than in science. In summary, the full moon illuminates the sky and also our imagination. Although scientific data does not support the idea that it significantly alters our behavior, its influence on the collective mind is undeniable. Every time we look up and see the full moon, we remember centuries of tales, beliefs, and questions about our connection to the cosmos. Sometimes, the true magic lies not in the facts, but in what we choose to believe. What makes some full moons appear much larger and brighter than others? The answer lies in a phenomenon known as a supermoon. A supermoon occurs when the full moon coincides with the point in its orbit that is closest to Earth, called perigee. But why is the moon not always the same distance from us? The lunar orbit is not a perfect circle, but an ellipse, which means that sometimes the moon is closer and other times farther away. When the full moon occurs right at that moment of maximum proximity, the result is a supermoon that can appear up to 15% larger and 30% brighter in the night sky. Can you really notice the difference with the naked eye? Although our brain can play tricks and exaggerate the size of the moon near the horizon, the difference between a supermoon and a regular full moon is subtle but real. To put it in perspective, if we compared a supermoon with a full moon at the farthest point in its orbit, the so-called micromoon, the supermoon would look like a 2 peso coin next to a 1 peso coin. It's a small difference, but when observed closely, the additional brightness and size can be impressive. How often can we enjoy this spectacle? Supermoons are not as rare as one might think. They generally occur between 1 and 4 times a year, depending on how the lunar phases align with the moon's position in its orbit. However, not all supermoons are the same. Some are closer to perigee and others a bit farther away, so their visual effect can vary. Astronomers calculate exactly when they will occur through precise measurements of the lunar orbit, allowing them to predict and announce these events in advance. In addition to their beauty, do supermoons have any real effect on Earth? The answer is yes, although in a very subtle way. When the moon is closer, its gravitational pull on the oceans slightly increases, generating tides that are a bit higher than usual, known as perigee tides. However, this effect is minimal and poses no danger. Throughout history, supermoons have inspired myths, songs, and observations. But essentially, it is simply an astronomical coincidence that reminds us of the dynamic and fascinating connection between the moon and our planet. Have you ever heard of a micromoon? While supermoons often steal the spotlight, micromoons are just as fascinating, though less known. But what exactly is a micromoon? It is a full or new moon that occurs when our satellite is at the farthest point in its orbit around the Earth, known as apogee. From our perspective, the moon appears a bit smaller and less bright than usual. How much smaller? Up to 14% less in apparent diameter in the sky compared to a supermoon, and up to 30% less luminous. It's as if the moon is playing hide and seek, moving just a little farther away to remind us that its orbit is not a perfect circle, but an ellipse. Why does this happen? The lunar orbit is an elongated ellipse, which means there are times when the moon is closer to the Earth and others when it moves away. When the full moon coincides with that farthest point, we have a micromoon. Although the difference is not very noticeable at first glance, astronomers and enthusiasts look forward to it with interest, as subtle phenomena can also be surprising. Additionally, micromoons can influence other celestial events, such as eclipses. And speaking of eclipses, what is a penumbral lunar eclipse and why does it often go unnoticed? Unlike total lunar eclipses, where the Earth casts a dark red shadow on the moon, in penumbral eclipses, only a faint shadow, called the penumbra, passes over the satellite. This happens because the moon crosses only the outer part of the Earth's shadow cone. The result is a slight decrease in the brightness of the moon, so subtle that many people don't even notice it unless they are paying attention or know it's happening. It's as if the moon has put on a translucent veil for a few minutes. But why are these penumbral eclipses interesting? Although they lack the visual drama of total or partial eclipses, they are a perfect demonstration of the precision with which the Earth, the moon, and the sun dance together. Scientifically, they allow us to study how the Earth's atmosphere filters sunlight and how colors change on the lunar surface. In fact, penumbral eclipses may seem insignificant, but they are part of a complex system of alignments and movements that influence our planet more than we realize. By connecting micromoons and penumbral eclipses, we realize that even the most discrete phenomena in the sky hide intriguing stories about the laws that govern our solar system. Who would have thought that a slightly smaller moon or an almost invisible eclipse could reveal so much about the dynamics and precision of our universe? Every event, no matter how modest, is an opportunity to look up and remember that behind every detail, there are centuries of observation and questions still to be answered. Can the moon set the rhythm of life on Earth? Although it sounds incredible, this satellite has acted as a natural clock for many living beings. The influence of the moon on biological cycles dates back to ancient times, long before modern clocks existed. Lunar cycles, lasting 29.5 days, not only regulate tides, but also the behaviors of numerous animal and plant species. Did you know that for some organisms, the moon is even more important than the sun for organizing their daily routine? In the oceans, for example, there are species of corals that synchronize their reproduction with the lunar phase. Literally, millions of corals release their gametes at the same time, right during a specific night of the lunar cycle. This phenomenon, almost choreographed by the light of the moon, allows fertilization to be more successful and for larvae to survive in mass. They are not alone. Certain fish, like herring, also plan their migrations and spawning according to the lunar calendar. This synchronization ensures that predators cannot easily anticipate their movements, increasing their chances of survival. But lunar influence is not limited to the seas. What do owls, crickets, and some night-blooming plants have in common? They all adjust their behavior according to the amount of light reflected by the moon. Some terrestrial animals take advantage of full moon nights to find mates, feed, or move around, while others, fearful of being seen by predators, prefer to stay hidden. Even in traditional agriculture, farmers have observed for centuries that certain crops germinate better if planted according to lunar phases, although science still debates to what extent this is a coincidence or a biological rule. And what about humans? Although circadian rhythms are more linked to the sun, there are studies suggesting that the lunar cycle may influence sleep, mood, and even the frequency of births. Some ancient cultures designed calendars based on the phases of the moon to organize harvests, rituals, and festivities. Today, the moon continues to mark time in the lives of many people, even though its influence goes unnoticed in modern routines. Thus, the moon acts as a silent metronome that accompanies the pulse of life on Earth, reminding us that, although we are surrounded by technology, we are still connected to cosmic rhythms. What do civilizations separated by thousands of kilometers and centuries of history have in common? The answer might be above our heads every night: the moon. Since ancient times, humanity has looked at the satellite and imbued it with meaning. Why did such different cultures find in the moon such a powerful symbol? In Egypt, the moon was seen as the manifestation of the god Khonsu, the nocturnal traveler who protected travelers and determined the passage of time. For the Aztecs, the moon had its own birth myth, featuring Coyolxauhqui, the lunar goddess whose fate was intertwined with that of the sun in an eternal dance of light and shadow. Have you ever wondered why the Islamic calendar begins with the observation of the moon? The answer lies in its role as a marker of time. Unlike the solar calendar, the lunar cycle was etched in the sky with an almost hypnotic precision. That's why, in cultures like the Chinese, the moon not only served to mark festivities like the famous Mid-Autumn Festival, but also symbolized harmony and family reunions. It was a reminder that, although life changes like the lunar phases, there is always a cycle of return. And what about the moon as a source of inspiration and fear? In ancient Greece, Selene was the personification of the moon, riding her silver chariot across the sky, while in India, Chandra was worshipped as a god who influenced fertility, health, and the fate of kings. In Oceania, Polynesian populations observed the moon not only for navigation, but also to read omens, believing that its brightness could alter the fortunes of people. The moon was, for them, a mystical compass and an oracle. Why is the moon so often associated with the feminine? Many cultures linked it to fertility and the cycles of life, noticing the similarity between the lunar cycle and the human menstrual cycle. Thus, the moon became a symbol of rebirth, mystery, and renewal. Even today, for millions of people, the moon remains more than just a simple satellite. It is a silent bond that unites myths, beliefs, and dreams of all humanity, reminding us that despite our differences, we all share the same night sky. Are we really close to seeing humans living on the moon? The idea of establishing a lunar base, once exclusive to science fiction, is now a real goal for space agencies and private companies around the world. But why is there so much interest in returning, and even staying, on the moon? Beyond prestige, the moon offers strategic advantages. Its proximity to Earth, its low gravity, and the presence of valuable resources, like water in the form of ice, open up a range of possibilities for exploration and technological development. What are the concrete plans to build a lunar base? NASA leads the Artemis program, which aims to bring the first woman and the next man back to the lunar surface in the coming years. This program plans to establish a sustainable human presence with modular habitats and the use of local materials, such as lunar regolith, to build shelters and protect against radiation. Other agencies like ESA, Roscosmos, and CNSA also have their own projects, and international collaboration is shaping up to be one of the keys to success. Even private companies like SpaceX are developing spacecraft and technologies to facilitate the transport of cargo and people to the moon. Is it really possible to live and work on the moon? The challenges are enormous. Extreme temperatures ranging from scorching heat to intense cold, an almost non-existent atmosphere, and constant solar radiation. However, science is finding solutions. For example, closed-loop life support systems, 3D printing with lunar dust to build infrastructures, and the use of solar energy to keep habitats operational are being studied. Water ice at the poles could be key, as it would allow for the production of oxygen and fuel directly on the moon, reducing dependence on Earth. What would a permanent lunar base be for? It would be much more than just a simple scientific camp. A lunar base would function as a laboratory to study deep space, test new technologies, and train astronauts in extreme conditions. Moreover, it could be the first step for missions to Mars and beyond. In simple terms, the moon could become the springboard that propels humanity into the next great era of space exploration. The dream of a human home on the moon is no longer just a matter of imagination. Each year, we get closer to making it a reality. What secrets does the moon hide beneath its grey and dusty surface? Beyond its nighttime beauty, the moon is a true treasure trove of resources. One of the most coveted elements is helium-3, a rare isotope on Earth, but surprisingly abundant in lunar regolith. Scientists have dreamed for decades of the possibility of using helium-3 as fuel in nuclear fusion reactors, a source of clean and nearly limitless energy. Today, there are still no commercial fusion reactors, but the idea of harnessing lunar energy remains a powerful incentive for exploration and space mining. Could the moon become the quarry of the future? Its surface also holds vast amounts of oxygen trapped in minerals, primarily in the form of silicon and aluminum oxides. Although the moon is not breathable, That oxygen could be extracted and used for both human life and to generate rocket fuel. Imagine lunar stations capable of producing their own oxygen and supplying missions beyond the satellite, opening the door to a true space economy. The moon also contains valuable metals for industry, such as iron, titanium, and aluminum. These materials, found in the regolith and in rocks known as lunar basalts, could be extracted and used to build infrastructure on the moon itself, thus avoiding the costly transportation from Earth. Additionally, small amounts of gold, silver, and platinum have been found, although in much lower concentrations than the main metals. The extraction of these resources raises intriguing questions. How could they be efficiently mined in such a hostile environment? Who would have the right to exploit them? Finally, water is one of the most valuable treasures recently detected. In the form of ice, it hides in polar craters, shielded from sunlight by perpetual shadow. Lunar water is not only essential for human survival, but it can also be broken down into hydrogen and oxygen, creating fuel for spacecraft. Are we on the brink of a truly self-sufficient lunar civilization? If humanity can overcome the technological and legal challenges, the resources of the moon could mark the beginning of a new era in space exploitation. Did you know that without the moon, life on Earth would be very different, and it might even be impossible as we know it? This natural satellite not only adorns the night sky, but also plays a fundamental role as a guardian of our planet. One of its most crucial functions is to stabilize the Earth's rotation axis. But why is this so important? The Earth's axis is tilted approximately 23.5 degrees relative to its orbit around the Sun. This tilt determines the seasons, the distribution of sunlight, and consequently, the global climate. The moon's gravity acts as an anchor that keeps this tilt relatively constant. Without its influence, the Earth's axis could wobble chaotically, drastically altering the seasons and even causing extreme changes in the climate, making it difficult for complex ecosystems to evolve. Can such a small satellite have such a big impact? The answer is yes, and the explanation lies in physics. If the Earth had no moon, the gravitational forces of other planets, like Jupiter, would have a much greater influence on our axis. This could cause variations of up to 40 degrees, compared to the mere 2 degrees it currently fluctuates. Imagine a planet where the North Pole could end up pointing towards the Sun for centuries, only to then plunge into an endless night. These extreme changes would make the climate unpredictable, hindering the survival of plants and animals adapted to stable cycles. But the protection that the moon provides doesn't end there. Its presence also helps to cushion the bombardment of asteroids and comets. Although it doesn't act as a physical shield, its gravity alters the trajectory of some objects that could impact Earth. Moreover, during the first few 100 million years of the solar system, the moon absorbed many of the impacts that, had it not existed, would have struck our planet directly. The craters on its surface are witnesses to that violent past, and each mark tells a story of indirect protection for life on Earth. Finally, the moon also contributes to the stability of the oceans. By generating regular tides, it promotes the mixing of waters and nutrients, which is essential for the development of marine life. If the tides were much weaker or irregular, coastal ecosystems, which are among the most productive on the planet, would not exist as we know them. Thus, the moon is much more than a mere companion in the night sky. It is a key piece in the delicate balance that allows life to exist on Earth. Is it possible for a simple jump on the moon to feel like flying? On the lunar surface, gravity is about 1/6 of what we experience on Earth. This means that a person weighing 72 kilos would weigh only 12 kilos up there. This microgravity environment not only transforms the way we move, but also has profound and surprising effects on the human body. What really happens to our organism when it leaves Earth's gravity for long periods? One of the first changes occurs in the muscles and bones. Without the constant weight of the body acting as resistance, muscles begin to weaken and bones lose density. It's like if you stopped using a bicycle. Over time, the gears rust and the mechanism becomes less efficient. astronauts can lose up to 1% of bone mass for every month they spend in microgravity. This phenomenon forces them to engage in intense exercise routines in space to try to slow down the deterioration, although so far, no Earth-based routine has been able to completely replace the natural gravitational pressure. And what about the heart? This organ, accustomed to pumping blood against gravity, has less work to do on the Moon. As a result, it can atrophy, and upon returning to Earth, astronauts may experience dizziness and even fainting. Additionally, blood and other bodily fluids tend to redistribute towards the head, which can cause the characteristic moon face seen in astronauts and lead to discomforts like nasal congestion or headaches. Can you imagine having a permanent cold while exploring another world? But the effects don't stop there. Balance and coordination are also altered. On Earth, the vestibular system in the inner ear works with gravity to keep us oriented. In lunar microgravity, this system receives confusing signals which can lead to disorientation and dizziness, a kind of space sickness. Even the perception of time changes, as the body loses many of the physical references it is accustomed to. In the face of these challenges, space medicine is constantly researching new ways to protect human health beyond Earth. From special suits to pressurized habitats and nutritional supplements, each advancement brings us a little closer to the possibility of prolonged stays on the Moon. Will it ever be possible for us to fully adapt to life on another world? Or will we always need the invisible yet essential embrace of Earth's gravity? The answer, for now, remains floating among the stars. What is special about lunar dust, and why does it represent one of the greatest challenges for technology in space exploration? At first glance, it may seem like just a fine layer of dirt, but in reality, lunar dust is much more than that. It is made up of tiny, sharp, and extremely abrasive particles, the result of billions of years of meteorite impacts. Unlike dust on Earth, which has been eroded by wind and water, lunar dust is as sharp as microscopic sandpaper. Why does this matter? Because these tiny particles have the ability to damage anything that comes into contact with them. During the Apollo missions, astronauts experienced firsthand the effects of lunar dust. Did you know that their spacesuits ended up covered in a grayish layer that was almost impossible to remove? The dust clung to everything: boots, gloves, tools, and even filtered into the spacecraft. It was like trying to clean up static confetti, but much more dangerous. This dust was not only annoying, but it also caused short circuits in equipment, scratched visors and seals, and jeopardized the integrity of suits and modules. Neil Armstrong himself described the texture of the dust as graphite dust, which gives an idea of its abrasive capacity. How does this dust affect modern technology? Think about solar panels and current scientific instruments. Lunar dust can coat and block sunlight, reducing the efficiency of the panels, which is critical when energy is limited. Additionally, being so fine and electrically charged due to solar radiation, these particles float and settle on delicate surfaces. Not even the most advanced seals can guarantee total protection. Electronics, motors, and even the joints of lunar vehicles can be compromised by the invasion of these microparticles. It's as if the Moon has its own defense system, a dust that tests every technological advance. Are there solutions to this challenge? Engineers have developed more resistant materials, improved sealing systems, and even technologies that use electric charges to repel dust. However, the challenge persists. Every mission to the Moon involves new tests and adjustments to prevent dust from damaging vital equipment or even endangering the lives of astronauts. Lunar dust is a reminder that in space exploration, obstacles can be as small as a particle, but with gigantic consequences. Why do some scientists consider that the Moon could be the key to conquering the rest of the solar system? The answer lies in its strategic position and unique conditions. In terms of space exploration, the Moon is the perfect midpoint between Earth and much more distant destinations, like Mars or the asteroids. Thanks to its low gravity, launching spacecraft from the lunar surface requires much less energy than doing so from our planet. It's as if the moon were a natural launch ramp. Taking off from there would be simpler and more efficient, allowing for the transport of heavier or more expensive payloads into deep space. But would it really be possible to build a launch base on the moon? That idea has been on the minds of engineers and scientists for decades. The use of lunar resources, such as regolith to build structures or even to extract oxygen, could drastically reduce the amount of materials we would need to bring from Earth. Additionally, there is a highly coveted material, helium-3, a rare isotope on Earth, but relatively abundant on the lunar surface, which could be key for the development of fusion energy in the future. If we manage to exploit these resources, the moon would stop being just a destination and become a true hub for space operations. Another great advantage is the possibility of manufacturing fuel on the moon. How? Through the water that has been discovered in the form of ice at the lunar poles. That ice could be split into hydrogen and oxygen, the basic components of rockets. This means that a spacecraft could land on the moon, refuel, and then continue its journey much farther than would be possible launching directly from Earth. The moon would function as a cosmic gas station, facilitating long-duration missions and opening the door to the exploration of distant planets and moons. Could the moon be our springboard to the colonization of the solar system? Although there are still many technical and logistical challenges, the idea is gaining momentum. Using the moon as an intermediate base could lower costs, reduce risks, and accelerate human expansion beyond our planet. Thus, this satellite, which for centuries has been a source of inspiration and mystery, could become the first major step toward a truly interplanetary humanity. What makes the moon so special among the natural satellites of the solar system? To answer this question, we must first understand that it is not the only satellite in our cosmic neighborhood. In fact, there are over 200 natural satellites orbiting the planets of our system, each with unique and surprising characteristics. But why does the moon stand out among them all? One of the key factors is its size in relation to Earth. The moon is unusually large compared to the planet it orbits. If we placed Earth and the moon side by side, we would see that the lunar diameter is approximately 1/4 of Earth's. Proportionally, this makes it one of the largest satellites relative to its host planet. Now, how does the moon compare to other famous satellites, such as Ganymede or Titan? Ganymede, which orbits Jupiter, is the largest satellite in the solar system, even larger than Mercury. However, Ganymede only represents a small fraction of Jupiter's size, while the moon, in comparison, is a giant next to Earth. Titan, Saturn's largest satellite, is famous for having a dense atmosphere and lakes of liquid methane, something completely absent on the moon. Despite the moon lacking a significant atmosphere, its rocky and rugged surface makes it a fundamental object of study for understanding geological processes beyond Earth. It's like comparing a perfectly polished rock to a gem full of cracks and scars. Both are fascinating, but for different reasons. Why do some planets have dozens of moons, while others have only one? Jupiter and Saturn, for example, act like celestial magnets, capturing numerous bodies due to their immense gravity. Mars, on the other hand, has two small moons, Phobos and Deimos, which appear more like captured asteroids than satellites formed from the planet itself. The moon, however, likely formed after a colossal impact between Earth and an object the size of Mars, giving it a distinct origin and a composition more similar to Earth's crust than to most other satellites. This difference in formation is crucial for understanding its history and its unique role accompanying our planet. Finally, how does the presence of such a large satellite affect a planet like Earth? The moon not only regulates the tides and stabilizes Earth's rotational axis, but it has also influenced the development of life and the geological history of our planet. No other natural satellite in the solar system has such a profound and complex impact on its host planet. In a way, the moon and Earth form a double system, almost as if they are dance partners on the vast stage of the cosmos. Thus, the comparison with other satellites only highlights the extraordinary nature of our lunar neighbor, whose presence continues to be a subject of admiration and scientific study. What do the ash from a campfire and the soil of the moon have in common? At first glance, both seem to share that characteristic grey tone. But why does the moon, which we admire shining in the sky so many times, appear with such dull colours when we look at it up close? The key lies in its composition. The lunar soil, also known as regolith, is primarily made up of fragments of rocks and extremely fine dust. Its greyish colour comes from a mix of minerals like plagioclase, olivine, and pyroxene, which dominate the lunar crust. These minerals, by not reflecting too much sunlight, give the lunar surface that opaque and uniform appearance. Is it true that the moon is completely grey? Not exactly. Although grey predominates, the lunar soil actually presents a range of shades, from light greys to darker tones, and even subtle brown or bluish hues in certain regions. The difference in colours is related to the proportion of minerals and the age of each area. For example, the so-called lunar maria, which are large plains of solidified basalt, tend to be darker because they contain more iron and titanium. In contrast, the lunar highlands, rich in plagioclase, appear lighter. If the moon were a pizza, the maria would be the most toasted parts and the highlands the palest. Where do those colours and materials come from? For billions of years, the lunar surface has been bombarded by meteorites and bathed in solar radiation. This process has fragmented the original rocks and created a layer of dust and tiny particles. Furthermore, the absence of an atmosphere means there is no wind or water to mix or erode the materials as on Earth. Because of this, the colours and composition of the lunar soil remain practically intact over enormous periods of time, preserving scars and traces of impacts that occurred millions of years ago. In fact, some grains of lunar dust have a layer of glass formed by the extreme heat of impacts, giving them a special shine when light hits them from certain angles. Is there anything more than just dust and rocks? Surprisingly, yes. The lunar regolith also contains tiny spheres of metallic iron created by the impact of micrometeorites. These particles, invisible to the naked eye but detectable through scientific analysis, contribute to the moon absorbing more light than it reflects. That's why, although it dazzles us from Earth, the lunar soil is one of the darkest materials in the solar system. Thus, the moon is much more than just a simple grey sphere. Its surface is a mosaic of minerals, colours, and secrets formed slowly over the history of the solar system. Could the moon have harboured life at some point? This is one of the most intriguing questions that science has posed about our satellite. If we think about what organisms need to survive, liquid water, a protective atmosphere, and suitable temperatures, the moon seems like the last place to look for life. However, scientific curiosity does not stop at first impressions. Have there been moments in lunar history when conditions were different from what we know today? During the first few 100 million years after its formation, the moon was a much more dynamic place than it appears now. It is known that during that time there was intense volcanism and that the surface was covered by boiling lava seas. But does this mean that there could have ever been liquid water? Recent analyses of rocks brought back by the Apollo missions have revealed traces of volatile compounds, including hydrogen, suggesting that water may have been present in the distant past, albeit in very limited amounts. However, without a significant atmosphere to protect it, any liquid water would have quickly disappeared, evaporating or escaping into space. What if life doesn't need the same conditions as on Earth? Some scientists have hypothesized that in the past, the interior of the moon may have had small reservoirs of water trapped in its mantle, shielded from solar radiation. In theory, extremely resilient microbes could have survived for a limited time in those protected environments. This scenario is more speculative than probable, but it has not been completely ruled out. In fact, the search for life on other worlds has taught us that life can emerge in unexpected places, from the depths of Earth's oceans to the most arid deserts. Currently, the conditions on the lunar surface are so extreme that the possibility of life as we know it is virtually nil. Cosmic radiation, temperatures ranging from scorching heat to extreme cold. The absence of an atmosphere and the lack of liquid water make the moon an inhospitable environment for any form of life. However, the moon remains a natural laboratory for understanding the limits of life and for asking ourselves whether, under very different circumstances, the spark of life may have ignited at some point on its surface or within. Although no signs of life have been found so far, each mission and each analyzed sample brings us a little closer to understanding not only the history of the moon, but also the mysteries of life in the universe. Why has the moon continued to fascinate humanity for thousands of years? Perhaps because at first glance, it seems like a solitary lantern in the night. But in reality, it is much more. It is a fundamental piece for life on Earth and a natural laboratory that holds secrets about the origin of the solar system. If the moon were to disappear tomorrow, what would happen to our planet? Tides would become chaotic, the climate would change in unpredictable ways, and even the stability of the Earth's axis would be at risk. This seemingly silent satellite is that essential. The moon is much more than just a celestial body orbiting around us. It is a silent witness to cosmic history and a key player in the balance of terrestrial life. Did you know that without its gravitational influence, life as we know it might never have evolved? Its presence determines the rhythms of the oceans, influences the behavior of living beings, and even marks the passage of time in the calendars of ancient and modern civilizations. The moon, in a sense, is the metronome that sets the beat of our planet. But what does the moon tell us about ourselves? Every crater, every grain of dust, and every trace left by astronauts tells a part of our own story of exploration and curiosity. From the earliest myths to the most advanced missions, the moon has been a source of inspiration, questions, and discoveries. Could it one day become a new home for humanity or a springboard to other worlds? The possibilities are as vast as space itself. In short, the moon is a constant reminder that we are not alone in the universe, but rather part of a larger and more astonishing system than we can imagine. How many mysteries remain to be discovered on its surface and within it? Every time we look up, the moon invites us to keep exploring, to never stop asking what lies beyond, and to marvel at the science and beauty that surround us. Thus, this satellite continues to be much more than just a simple nighttime companion. It is a symbol of our ability to dream and achieve the impossible.